Dear students, how are you? I hope you are well. I am also well. Dear students, welcome to everybody in আমাদের পাঠশালা conducted by Manipur Uccho Bidyalaya and College. Dear students, today we will discuss of class 11 and 12. Subject is physics of second paper and chapter 1, which is thermodynamics. Dear students, you have already discussed about 3 lectures on thermodynamics. Now we will discuss on 4 lectures on thermodynamics. Dear students, after studying this lesson, you will be able to explain the second law of thermodynamics, explain the principle of Carnot cycle, and explain the construction of Carnot engine. Okay, dear students, previous we discussed about the first law of thermodynamics. Today I will discuss of second law of thermodynamics. You know that all energies are transformed into heat energy, but heat energy cannot be transformed into other forms of energy easily. If we converted heat energy into other forms of energy, there will be an engine or device, and this device is called heat engine or machine. Without machine, heat cannot be transformed into other forms of energy. Firstly, second law of thermodynamics states Carnot's. Now, different scientists have stated the second law of thermodynamics in different ways, though the statements are different, but the main theme is similar. According to different scientists, the law is as follows. First, the statements of Carnot's statement. It is impossible to build a machine that can convert a definite amount of heat energy to mechanical energy completely. That means if a heat energy is converted to mechanical energy, then a machine is compulsory. Now, Clausius statements, without any external energy, no automatic machine can transfer energy from an object lower temperature to high temperature. Dear students, you know that energy is transformed naturally from high temperature body to lower temperature, but if we transfer the energy from lower temperature to higher temperature, then a machine is needed. Now, Planck's statement, it is impossible to make a machine that can absorb heat energy continuously from a heat source and convert the energy completely to work. Now, Kelvin's statement, it is impossible to get a continuous flow of energy by making an object cooler than its surroundings. Now, we will discuss about the Carnot's engine. What is Carnot engine? Scientist Sadi Carnot devised an ideal engine to convert heat energy to a mechanical energy which is free from all imperfection of an actual engine is called Carnot engine. And the constructions of Carnot engine. The Carnot engine is only an imaginary one. It is not possible to construct such an engine in practice. The different parts of a Carnot engine are shown in the figure below. Okay, there are four parts in the Carnot engine. First one is cylinder, you can say. Cylinder C with perfectly non-conducting walls and a perfectly conducting bottom. That means the three walls are conducting walls and bottom layer is conducting. It is fitted with a perfectly non-conducting and frictionless piston P. An ideal gas is enclosed in the cylinder which acts as a working substance. Now, heat source T1. The heat source is a hot object with a very high thermal capacity is maintained at temperature of T1. Any amount of heat can be taken out from it without changing its temperature. Now, heat sink T2. The sink is a cold object with very high thermal capacity is maintained at a lower temperature of changing its temperature. And last one for heat insulated platform or heat insulated stand. A platform made up of completely insulating object on which the cylinder is placed. There is students here two sources. One is heat source and another one is sink. Here heat source is the very high temperature and sink the temperature is low. Now, Carnot cycle. What is Carnot cycle? Carnot cycle is a cycle in which the working substance starting from a given condition of temperature, pressure and volume is made to undergo two successive expansions, one isothermal, another adiabatic, and then two successive compression, one isothermal and another adiabatic, and then brought back finally to its initial condition is called Carnot cycle. Dear students, you can observe here total process is 4 steps. These 4 steps into 2 sections. One is expansion and another one is compression, and expansion is divided into 2 portions, isothermal expansion and adiabatic expansion, and also compression is isothermal compression and adiabatic compression. Okay, and you see the source, sink and insulator, and this is a cylinder. Dear students, now we will discuss the Carnot cycle. How Carnot cycle working? Dear students, here the working substance of ideal gas is enclosed a cylinder. First one, the cylinder is placed on a heat source. After some time, the temperature, volume and pressure is gains of the ideal gas of heat source or from the heat source. In this condition, the pressure is P1 and volume is V1, which is indicated in the diagram at point A. Here you can see the gas is expansion from A to B. After completing the process, the pressure of the gas is P2 and volume will be V2. Now, the cylinder is placed from the heat source to insulating platform, and for the And for the motion of inertia, the gas is also expanded. Here you can see in the figure from B to C. After completing the process, the pressure of the gas will be P3 and volume will be V3. These two processes are the expansion process. First one is isothermal process and second process is the adiabatic expansion process. Now, again, the cylinder is placed from insulating stand to the sink. After some time, the temperature of the gas will be gained of the sink T2, and this step or process, the volume of the gas will be decreased due to the temperature of the sink. Here, the sink temperature is comparatively lower than the heat source. So, in this case, the volume of the gas will be decreased and the pressure will be increased. And after completing this process, the pressure will be P4 and volume will be V4. Finally, the cylinder is placed from sink to the insulating stand or insulating platform. And after completing the process, the pressure of the gas will be P1 and the volume will be V1 and back to the same point or previous point A. That means one cycle is completed here. This is a Carnot cycle. Now, how work is done here in 4 steps we will discuss now. First one, isothermal expansion process, which is shown in the graph AB. Work done W1 equals to, V1 to V2 PdV. Here first step is the isothermal expansion and work done is W1. Initial volume is V1 and final volume is V2 and pressure is P. Now, we can calculate the integration equal integration V1 to V2. Dear students, PV equals to RT for isothermal process, or P equal RT divided V. Now, replace the pressure P equals to RT divided V into dV. Here R and T is a constant. Now this constant is placing outside of the integration. RT integration V1 to V2 dV divided V. And integration dx by x equals to ln of x. So according to this law, we can write integration dv by v equals to ln of v equal RT ln v, both side third bracket v1 to v2. Okay, equal RT ln V2 minus ln V1 equal RT ln V2 divided V1. Therefore, W1 equals to RT ln V2 by V1. This is the work done for isothermal expansion process. And you shown in the graph here. The graph AB is the region of ABGE. We can write equals to A, B, J, A, area of area of A, B, G, E region. Okay. Now we can calculate the work done of adiabatic expansion from B to C. Since you know, dear students, in adiabatic process there is no heat enters into the system, or there is no heat released from the system or cylinder. Now work done in step 2, that means in adiabatic expansion from BC graph, W2 equal integration V2 V3 PdV. Since the adiabatic process, we can write PV gamma equals to constant K, or P equals to K divided V gamma equals to P V to the power minus gamma equal V2 to V3 KV minus gamma into dV. Equal, here K is a constant, so we can write the constant outside of the integration, V2 to V3 V gamma dV, V to the power minus gamma into dV equals to K. You know, integration of V to the power minus something, V to the power minus gamma plus 1 divided minus gamma plus 1, third bracket V2 V3. Or W2 equal K B to the power 1 minus gamma divided 1 minus gamma, both side, third bracket V2 V3 equal K divided 1 minus gamma V to the power V3 1 minus gamma minus V2 1 minus gamma, both side, third bracket equal. Now multiplying K 1 by 1 minus gamma, K V to the power V3 1 minus gamma minus K V2 1 minus gamma. Equal 1 divided 1 minus gamma equal P3 V3 gamma V3 1 minus gamma minus P2 V2 gamma into V2 1 minus gamma, since according to the law of PV gamma is equal to constant, equals to 1 divided 1 minus gamma P3 into here minus the power of minus gamma and plus gamma is cancelled, so we can write P3 V3 minus P2 into similarly here V2 equals to 1 by 1 minus gamma RT2 minus RT1. You know, for isothermal process, PV is equal to RT for 1 mole of gas. So you can write equals to here R is common, RT2 minus T1 divided 1 minus gamma. This is the work done for adiabatic expansion process. And in respect of the figure, we can write equals to BC area of BCAJ region. Okay. Now, step 3, which says isothermal contraction process. Isothermal contraction process, that means CB graph. Work done is W3. In this case, we can write integration. Here volume is V3 to V4 PdV. Okay, dear students, since the process is isothermal, so here is the temperature is only one temperature. So we can write for isothermal process V3 to V4, you know PV equals to RT or P equals to RT divided by V. So we can write in replace of P, RT divided V into dV equal integration V3 to V4, and here R and temperature is the constant, and this constant can write in the outside of the integration RT dV divided V equals to RT, and you know the integration of dV by V equals to ln of V. So here we can write integration dV by V equals to ln V, and the limit is V3 to V4 equals to RT ln V4 minus ln V3. Since you know minus logarithm, we can write the division form. Finally, the work done will be in this process W3 equals to RT into ln V4 divided V3. Okay. Now finally, the work done in the fourth step, that means adiabatic contraction or adiabatic compression process. That means here graph is D2A, that DA graph. DA graph. Work done W4 equals to integration V4 to V1 PdV, and this process is adiabatic process. For this reason, we can write the formula is PV gamma equals to constant or P equals to K into V to the power minus of gamma equals to V4 V1 K V to the power minus gamma into dV. Here K is a constant equals to, so we can write the constant outside of the integration V4 to V1 V to the power minus gamma into dV equal K V to the power minus gamma plus 1 divided minus gamma plus 1 V4 to the power V1. Or W4 equals to K divided 1 minus gamma V to the power 1 minus gamma, both side third bracket, V4 to V1 equals to K divided 1 minus gamma V1 1 minus gamma minus V4 1 minus gamma equals to multiplying K on the inner side 1 by 1 minus gamma K V1 1 minus gamma minus K V4 1 minus gamma equals to 1 by 1 minus gamma P1 V1 gamma V1 1 minus gamma minus P4 V4 gamma V1 minus gamma equals to 1 by 1 minus gamma into P1 V1 minus P4 V4 equals to P1 V1 minus P4 V4 divided 1 minus gamma. This is the work done of adiabatic compression process, and the region of work done equals to W4 equals D F E A region. Now total work done on the system will be W1 plus W2 minus W3 minus W1, because W1 and W2 is positive because of the gas A work done is positive by the gas, and work done in negative the work done on the system. For this reason W3 and W4 is negative and W1 W2 is positive. Okay, dear students. Thank you everybody. Today's class is finished.